right, guys, welcome to another episode of CUDA Education. Today, I simply want to focus on one function call. Um, kind of have a lot to go through, but I want to do it as efficiently as possible. But I also ask for your patience in the process. A lot of moving parts with this one. And it's I'm gonna try and do it as straightforward as possible, highlight the things that I see, um, give you guys some homework, and we'll take it from there. So first of all, guys, if you want to be able to run these examples on your machine, you need to get tutorial number 1, which is installing the Vulkan API on a Windows-based machine with a Vulkan-capable GPU. If you want to be able to run the ray tracing examples, you need a ray tracing capable GPU, right? But Vulkan-capable Windows-based is what you need for tutorial number 1. That is installing the Vulkan API on your machine. If you want to install all these examples, you need to get tutorial number 13. Tutorial number 13 is the installing all of these examples. If you want to be able to get the ray tracing stuff running, you need to have a ray tracing capable GPU. For NVIDIA, it's RTX and later. I can't talk about the other vendors, AMD and Intel, right? So we're running with these examples right now. So again, Windows machine, GPU, Vulkan capable GPU, and then if you want the ray tracing stuff, this is a ray tracing example. You need to make sure your GPU is ray tracing capable. All right. Okay, so the topic of today is a function called tracerayEXT. All right, tracerayEXT. This is the function call that this is the function call that we are talking about today. TracerayEXT, right? I have it. This is the long call, but I broke it down just so that we could all see it in one view, right? tracerayEXT. In simplified terms, this is the call. This is the call that basically allows for. This is the call that allows for us to generate rays into a scene. So notice that generally it is one of the last calls in either of the shaders. Now, for you guys that haven't been following along, we are in the shadows set of ray tracing shadows, or the shadows set of videos, right? The series. You could see in the labeling of how I label the videos. This is the shadows series, okay? We have our main algorithm. We have the ray tracing shadows.cpp, which is this guy here. And then as part of the algorithm, we have some shaders. We have 4 shaders, but our focus for today is the RayGen shader and the hit shader. So these two guys, closest hit and the RayGen. All right. Those are our 2 priorities for today, which we'll be focused on. I notice I have them side by side. That's basically what I'm going to be focusing on. As you guys know from the previous videos, if you haven't been following along, the RayGen shader is responsible for generating primary rays into the scene. So It is how everything gets started. These primary rays basically shoot out from the camera lens into the scene, right? So whatever we see in on our monitor is basically as a result of these primary rays being shot from the camera into the scene. If we rotate the object in the scene, which we do a lot of times, then a new set of rays are shot into the scene and we get to see what happens at that new angle, right? But again, the only thing rendered is what we basically see from the primary rays, which are shot from the camera. Okay, so the camera is like the monitor, it's like our eyes, whatever we're seeing, it's like that's what the ray gen is. It's shooting initial primary rays into the scene. As you guys know, at this point, um, when we shoot rays into a scene, we eventually hit stuff. So we might hit the object, we might hit the platform, we might hit what have you, right? So we hit stuff, right? So we have our platform and we have the object, and the object casts a shadow. Okay. So this tracerayEXT is what basically allows us to generate primary rays into the scene. In the closest hit example, the tracerayEXT is what is responsible for generating the shadow rays, the shadow test rays, or the shadow rays into the scene. That is basically the reason why we have this, and the whiteboard edition in this series outlines this very clearly. This is responsible for seeing whether there is any obstruction between the point of contact of the primary ray, the point of contact that at which there was a hit in the primary ray, and so that point, so the primary ray shoots into the scene and it hits something. Where it hits, another ray, a shadow test ray, is being shot from that point of the hit to the light source. If anything interrupts that shadow test ray from that point to the light source, then we deem that pixel, or we deem that region, or we deem that area, that hit point, to be a shadow. Okay? If there's a clear view from that hit point to the light source, then we know that that point is not a shadow and it is considered lit, or it's free to basically take in whatever the light source is spewing out or whatever, right? It's not considered a shadowed point. Okay, so again, this tracerayEXT in the hit shader, it's launching the shadow test ray, or the shadow ray, to find out whether our point is a shadow or it's a lit point. Okay, and for every pixel on the screen, for every pixel in the application, this is being done. All right, so this is all I'm trying to discuss today, this tracerayEXT. All right, I guess just for ease of use, you notice that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 arguments for this ray. All right, for this one, I assume 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 arguments for this ray also, for this function also. Notice in the hit shader, it says trace ray shadow and offset indices to match shadow hit miss shader group indices. We'll get to that. All right. I was hoping a little bit nicer. But anyway, so we have our generation, our ray gen shader, that does the primary rays, and then we have our shadow rays, shadow test rays that does our shadow test. So remember, primary rays shoot into the scene. When it hits something, it launches a second shadow test ray from that point of the hit to the light source and tests whether that point is shadowed, or it's a lit point, or it's, you know, it's free to basically be affected by the light source. If it's shadowed, it's unlit, it's kind of shadowed as you see in the application. And if it's lit, it's, you know, it's lit up, or it's free to be affected by the light source, right? All right. We talked about payloads. So let's just deal with the payload. So the very last argument for tracerayEXT, and let me just okay, the very last argument for tracerayEXT is the payload location. So these rays, they're not just carrying, they're not just rays, right? They actually have cargo. They have checked baggage, they have carry-on baggage, and they have over personal item, right? So you have checked baggage, carry-on baggage, and personal item. Okay? Make sure to stow your stuff in the overhead bins, as items may shift during flight. Oh, and make sure you know how to do it, because items may shift during flight. Or be careful when you open your overhead bins, because items may have shifted during flight, and you can hit somebody with your luggage in the overhead bin. Whatever. For you guys that love to travel, you know what I'm talking about. All right, so we have payloads for the tracerayEXT. We have payloads, okay? So here we have a payload. This payload, it's not a variable name, it's a location number. So here for the RayGen, we have location number 0. Why do we have location number 0? Because it is carrying a variable called hit value. Okay? I don't really want to get into hit value too much, but just know that hit value is sort of like the accumulation of everything that happens. So it basically, it's showing everything that we see, right? So, you know, you're not just shooting stuff into the ray. I mean, you're not just shooting stuff into the scene. You actually need a mechanism to actually record what happens. Like what color is that point? What's going on with that point? You know, all that stuff, right? So you need a variable to do that. I really don't want to get into this variable too much right now, but hit value is sort of our way of recording and knowing what's going on for that particular ray. Okay, so the payload is sort of like, it's almost like a black box in a plane, right? You need to record what's going on in the flight. All right, so you have to record what's going on in the flight. Okay, so that's what this hit value is, and it's affected by everything, and it's passed around between shaders and all that stuff, right? So we have a payload of hit value at location 0 inside of this primary ray, um, tracerayEXT call. Okay, so notice that this variable at location 0, which is hit value, is then being used in sort of the image storage buffer, image buffer, or whatever. But basically what I'm trying to say is that notice that we use this hit value here again. So we call the trace RayEXT, and then we take whatever happened in that ray, we then use it here to, I guess, display to the screen or something. I don't know. But we use it here. So this is this right here, this relationship right here is our way of actually getting a result from our tracerayEXT. So it's we launch array with a payload, and then whatever is recorded in that situationship is being used here to display to our screen and all of that, right? Image store, whatever. I don't want to get into that function. That's not the priority of this video. But just know that this tracerayEXT, we launch a payload at location. We launch array with a payload at location 0, which is our hit value variable, and then we use that same hit value variable after the call. So that's how we know that, like we get a result out of this thing. Let us go to the hit shader. So the hit shader, the very last parameter is a number 2, which means location 2. So what is that location 2? Location 2 is our shadowed variable. We have sort of discussed this in the previous couple of videos. I don't know if it's the one before that or the one before the one before that, but we have discussed this shadowed variable. Okay, notice that this shadowed variable is being it's being originated in the hit shader. So remember, we talked about ray payload ext, and we talked about ray payload in ext. Well, ray payload ext is when we're originating a variable. So we're originating shadowed of type bool, right? So this is a variable that we originate here in the hit shader. And then we basically launch the shadow test array or the shadow array with the payload of the shadowed variable. So we launch the shadow array, and we have a payload of shadowed variable, okay? And notice that also in this example, after we generate our array, we do some processing with that variable. Remember now, this array is it does something, but then we need to be able to like actually get a result from the array, and we get that result from the shadowed variable. The same, this and this is the same guy. Okay, it's the same guy. I know it's playing tricks on you here by using the number 2, but that's just how the Vulkan gods have it, or whoever is responsible for this stuff. And it's because this is at location 2. Okay, so we have location 2 shadowed, and it's used here. And then if shadowed, so if it's shadowed, then we do something with it, right? And basically notice that we are tinkering with the hit value stuff, right? Which goes back to our guy here, right? It goes back to our guy here, right? Which is this is kind of what we see, right? But it's all being communicated back. So if shadowed, blah, 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 and then we do some stuff. I discussed this shadowed stuff. I don't want to get into it too much, but all right. So we have at least gone through to the last argument in tracerayEXT. All right, top level acceleration structure. The top level acceleration structure is just the scene to traverse. Remember, top level acceleration structure is sort of like instances and stuff, so it's just a scene to traverse. So top level acceleration structure is a scene to traverse here. For in the region, and in the hit shader, it's the same thing. All right. Let's not. Yeah, not gonna get into it that too much. Okay. Maybe this variable is declared elsewhere. Okay. All right. So we have that. Let's do, so we've covered this one, and we've covered this one, right? We've covered this one, and we've covered this one. All right, so we're in good hands with Allstate, maybe. Anyway, all right, so we've covered those two arguments. Let's get into the origin. So what's the origin of this ray? Okay, so we have origin here. Okay, origin.xyz. How creative, guys. And we have origin here. All right, let us investigate. So this origin basically is, in a nutshell, it's where the camera is, right? So we're originating a primary array from where the camera is. There's the logic, there's the math here. You guys are free to dive into it to your heart's content. Here is all the logic, but yeah. All right, so this is where the camera is. And this is let's I guess this would be I guess we'll just say this is the hit point, right? So right, so this is your hit point, right? This is basically describing at what point did you hit something. So we're originating array starting at the hit point, right? Because remember, we have to go from the hit point to the light source. All right, so that's what the origin is, and here is the math for that, right? We're not going to dive too much into that right now, but just know that's what that is. Okay, so this is from the camera, and this is from where we hit something. um let us do we'll just do T min and T max next. It's basically how long you want to search for, right? So T min and T max is how long you want to search for, right? Like how long you want your rate to traverse, and what you want to count as, what interval you want to count as being valid. The thing is that, like, for T-min, I know that you don't want it to be too small, because you could self hit or like hit something in like the lens of the camera or something like that. It's what they call acme. Like if you hit something like that's part of the assembly that you're using to shoot out rays. Don't ask me what all that means, but basically, like, there's a small distance from where you start to count stuff, and it's away from the camera because you don't want to self hit. And then max is where you want to, the farthest point at which you will count stuff. That so if you hit something outside of T max, then it won't count. And obviously, if you hit something between T min and T max, then it will count, right? So that's all T min and T max is. We have T min and T max here. We have T min and T max here. All right, so we're good with those. All right, direction XYZ. All right, let's do that one next. So direction XYZ. So that's the third to last parameter. Direction XYZ. This is what direction you want your vector to go in, right? And again, for you math buffs, you could digest this to your heart's content. Okay, you could digest this stuff to your heart's content. That's the math for the direction, right? So for RayGen, the direction is from the camera into the scene, right? Basically where we're pointing the camera. And then for the hit shader, that launch, that shadow ray launch is basically light vector. We're going from our point to the light source, right? Right. So notice that we're trying to figure out what is the light position, of our light source, right? So that's what light vector is, right? For the camera, we always use unified buffer objects, UBOs. That's something for a different video, but basically we're trying to figure out what direction are we shooting our shadow test ray. So that's what light vector is. All right, so we've pretty much done all of these guys here now, plus this guy. All right, so all of these guys plus this guy. All right. Okay, we got to get into ray flags. Okay, so ray flags in the RayGen call, in the RayGen primary ray initiation, right? We use GL ray flags opaque EXT. All right, GL ray flags opaque EXT. That's what we use for this call here. All right. In the hit shader, we use all these guys. All right. And this is where your guys' homework comes in. So homework for you guys, you have to figure out what are these flags and why do we need them. So for the ray coming out of the camera into the scene, we just have one ray flags opaque EXT. Come on, guys. You guys have homework. Tell me in the comments below what these flags are. And then for the shadow ray, for the shadow test ray or the shadow ray, we have a lot more flags. We have three more flags. We have three flags. Instead of one flag, we have three flags. You guys have to tell me what these flags stand for and why are they there. Okay. Yeah, I don't want to get into the flags themselves. Terminate some of it is kind of self-explanatory, but one of the things that you have to sort of appreciate is that for the shadow ray or the shadow test ray, you have to understand that the this ray is being originated somewhere within the scene of everything that's going on in your scene, right? So there's a lot more things that you kind of need to either disregard or count or not count, or sort of you sort of have to butter it up a little bit. You sort of have to like modify it heavily to make sure that what you're actually counting as an actual event or not counting as an actual event is what you want. So you sort of need to put more flags in that ray for the initial ray into the scene. You don't really need as much flags or as modification, right? So that's sort of homework number 1. There's 2-part homework. Homework number 2 is call mask. Okay, so you guys need to tell me what call mask is and why it is important. I'll give you a little preview. It has something to do with, again, like what I said with the ray flags, is what do you count and what do you not count, right? And you sort of pin stuff. Um, you know, it's your way of like helping you to figure out um, what you want to count and not count, right? It's a weird thing, you know, because like it's just weird. There's no two ways to describe it. This is these call mask things and like what they use for bitwise and all that. It's what makes people afraid of computer programming. But we're not scared. But you guys, you have your homework. You got to tell me what call mask is and what it's used for, and why it's used in tracerayEXT. All right. But again, it has something to do with negating or not negating specific things in sort of the traversal of the ray. Um, maybe I'll get to it again in another video. I don't know. All right. Shader binding table offset. These two guys is shader binding table record offset and shader binding table record stride. This is just sort of, you know, making sure the GPU knows where things are and resources are and stuff like that. It's 0, 0 in our case. For the shadow ray, it's also 0, 0. All right. Okay, we're almost done, guys. We're almost done. Notice here though that the call mask is this guy, right? So the call mask here is call mask, which is this guy here, and then the call mask for here is this guy here. Okay, so we have 0, 0 for the shader binding table record offset and the shader binding table record stride, right? I don't want to get too much into it, but you guys, you know, I have many videos on the shader binding table, and like you kind of have to connect up the GPU with resources and stuff like that. So that's where assets and everything. So that's where the offset, the initial offset, and then the stride come in, right? But let's leave it at that. All right, we're down to our last variable, last but certainly not least. Last but certainly not least. So we've done top level acceleration structure, array flags, the call mask, your homework assignment. We understand shader binding table, offset, and stride, the origin. Oh yeah, the array flags is also your homework. So the array flags and the call mask is your homework. We've done the origin, we have done tmin, we have done direction, we have done tmax, and we have done the last variable, the last parameter in the call, right? Same here. We have done top level acceleration structure. We have done, well, your homework is the array flags. Call mask is also your homework. So right here, a nice little homework set for you guys. Shader binding table record offset is 0. Shader binding table record stride is 0. We have this one thing that we have to deal with. So that's our last thing. We have origin, we have tmin, we have light vector, we have tmax, and then we have our very last parameter, which is the payload stuff. All right. So now we have to get to the very last argument that we have to cover. It's the last argument, I mean, the very last thing that we have to cover, you know, that we have to cover. It's last but certainly not least. All right, so for tracerayEXT in the RayGen, we have a value of 0. However, in tracerayEXT in the hitch shader, when we're doing the shadow ray, when we're setting up the shadow ray, we have a value of 1. All right. So we got to figure out why is it 0 in RayGen and 1 in the hit. Okay. Um, it's 0 in regen because here this relates to our simple miss shader. Okay, so I actually didn't want to open it up, but this relates to our miss shader. Okay, so we have our miss shader, right, which is our general miss shader. So remember, primary ray traverses the scene. If the ray doesn't hit anything, we get our sky model, right? That's just the general miss shader. All right, so our sky model is the blue that you see here. Okay, traverse the scene. If you don't hit anything, you give me the color blue, right? Traverse the scene. If you don't hit anything, give me the color blue, right? But then we also have another shadow mist shader that at this point, go to the light source. If you hit anything, it's shadowed or it's not shadowed, right? What have you. So for our regen, what's coming out of the camera, we just care if it's a miss, it's blue. That is index 0. All right, that is index 0. For our hit shader, our shadow miss is index 1, and that's actually this shader, right? So we have our miss, blue, this is the color blue, and we have our shadow, right, which toggles the shadowed shadow mist, right? Toggles the shadow on and off. All right, so for 0 here in our regen, we talk about the blue stuff. For our closest hit, for our shadow test ray, we are pointing to this this miss the shadow mist shader. Okay, so that's all the differences between this and this. Now, why it's 0 and 1 and you know why it is the way it is and all of that stuff, we got to dive into create shader binding tables, right? And you could kind of see that, like, we're using 2 mist shaders, so we need to get 2 handles for the mist shader binding table, blah blah blah. This is like memory operations where, you know, we're pushing 2 different shaders, 2 different mist shaders into our setup, right? Into Vulkan and into everything that we're doing. So that's where the 0 and 1 goes, and why we have 2 different values for this particular one, for this particular argument. But it's a very important thing, and I'm not trying to downplay it or anything, but we get into memory operations and all that stuff once we start to deal with why it's 0 and 1, right? Which I don't really want to get into right now. If I do a Control F miss, what is this? Ray generation, miss group. We have our shadow miss, shadow.rmiss, and our miss.rmiss, right? So you can see here it's 2 different miss groups that we're dealing with, right? And yeah, that's sort of the gist of it. So we've done all the arguments for the tracerayEXT, but as you guys can see, we've now done all the arguments, and we have sort of dived into everything as it relates to generating a ray, whether from the ray generation shader or from the hit shader. And that's pretty much it. That's what this video is about. If you guys, as another piece of homework, dive into how this is set up as 0 and this is set up as 1 for pointing to the two different shaders, the two different mist shaders, right? So again, guys, if you want to, if you guys want to, run these applications on your machine, um, you need to make sure you have a Windows computer with a Vulkan-capable GPU, preferably one that's ray tracing capable. Tutorial number 1 is the Vulkan API installation. I walk you through a video walking you through that. Tutorial number 13 is the is the is all of these examples here. These examples are created by Sascha Willems, so shout out to him. We are going through, the examples for Vulkan. Vulkan is really cool. For all of you artistically inclined people, it's worth investing in learning Vulkan. All right, guys, thank you for watching. I'm at 42 minutes, so not too bad. For what we have covered, we have kind of, we have done well. So I need to put back my functions the way they were. So we have done top level, ray flags, call, mask, offset, shader binding table, stride and offset, offset and stride, the miss index, the origin, tmin, the direction that we want our ray to go in, tmax, and also our payload variable. All right, so you guys are a little bit closer to understanding the full scope of Vulkan. You should be proud of yourself. Thank you for watching. This is Kuda Education. You guys know what to do with the YouTube channel. Like, subscribe, all that good stuff. Notification bell, all of that good stuff. Have a great day.